Hello everybody, I'm presenting the research results done during the short-term scientific mission which was supported from the cost action Actinpak. I'm Vrabic Brodnjak and University of Ljubljana, Faculty of Natural Sciences and Engineering, Department of Textiles, Graphic Arts and Design in Ljubljana, Slovenia. The STSM was held in the University of Chemical Technology and Metallurgy in the Department of Pulp, Paper and Printing Art in Sofia in Bulgaria, and it was preceded with the supervision of Dr. Dimitrina Todorova. The duration of STSM was from 27th of September until 4th of October 2016. The common interest was to prepare paper samples containing bio-based components which will be included as fillers and not as coatings. And we want to investigate the changes in paper properties. Well, this kind of paper could be used as packaging material with great barrier properties and to be at the same time good and sufficient substitute for non-recyclable materials used in this field of packaging. For preparation of paper samples, we used pulp prepared from softwood and hardwood. We also used two polymers, Chitosan and rye starch, as fillers, and we add also the retention additive, modified cationic polyacrylamide. Paper sheets were prepared using 6 different variations of Chitosan, rye starch, pulp and additives. Here you can see all the mixtures. We prepared, as you see, 6 samples. First 2 samples have only pulp. The second sample has also the retention additive. But with samples 3 and 6, we made a combination of Chitosan and rye starch using different concentrations. As you can see, here was followed the preparation of pulp. 2000 milliliters of pulp was mixed, and then the Chitosan and rye starch were added. The mixing proceeded, and after that the retention additive was also added. All samples were prepared on paper laboratory machine, as you can see on the picture. And here is the final paper sheet, which is not dried. Samples were dried at 90 degrees Celsius for 7 minutes. After that, we have made the analysis of pulp and analysis of paper sheets. From the results, where the analysis of pulp has been done, it can be seen the differences in turbidity and the watering. The turbidity and the watering time has been measured, and usually the watering ability gives us indirect information about the flocculation ability of the paper suspension. Not all of the examined bio-based combinations have positive effects over the accelerated drainage of the paper suspension, as you can see presented in the table. Best results were obtained in the presence of 7.5% of Chitosan, followed by the combination of 5% of Chitosan and starch. If we see the results of the turbidity of the white waters, the results are similar to those for the dewatering ability, but here all the examined combinations have positive effects compared to the sample 1, where only pulp was used. The best results were obtained for sample 5, where 7.5% of Chitosan was included, which means that the white waters are clarified and the flocculation has its optimal conditions. We have made many analyses of paper sheets, from grammage, thickness, specific volume, density, smoothness, air permeability, bending resistance, water retention, color difference, and surface. As expected, the thickness of the samples has mostly the same values. The changes were at specific surfaces density, as you can see presented in the table. Grammage was the same at all samples. It was 80 grams per square meter. And there are differences in the COB value and the water retention, because the ability of fluids to penetrate the structure of the paper is highly significant property to the use of the packaging paper. And from the obtained results, the addition of Chitosan rye starch decreased water absorptiveness, and the higher the concentration of the solution was, the higher resistance towards water penetration has been detected. It is known that paper is highly porous material composed of felted layer of fibers and additives, and they can cause the variation of many properties, and one of them is for sure the smoothness and the air permeability. As you can see from the presented results in the figures, smoothness was better at samples with hydrogen and rice starch when the amount of biopolymers increased. The air permeability was the worst at paper where only pulp was included, with the addition of biopolymers and retention additive. Of course, the structure of the paper became more even, filled, and of course, the properties improved. For the packaging materials, bending resistance is very important. All samples have shown that, especially where the biopolymers were added, that their bending resistance increased. And the best results were at sample where 7.5% of hydrogen rice starch combination of the solution was included. Regarding the color difference, as expected, there are differences, as you can see after the results shown in this table. For hydrogen, it is known that it has yellowish appearance and therefore it has an effect on color in the paper. At samples where the rice starch was added, the color difference was lower because rice starch is a white powder and has an effect on final paper appearance. With the right amount and ratio of rice starch, we could avoid this problem, but we should be very careful because with the addition of the rice starch, microbial properties can decrease. With the scanning electron micrographs, we have proven the difference between the samples, as you can see on these pictures. Results provided that the hydrogen and rice starch have great impact on the paper properties. The surface of this sample is more even, there are big areas of filled hydrogen and rice starch mixture, and the higher amount of the solution gave the paper better appearance and more even surface. And we assume that this will also have an effect on printing properties. The presented results expected that our scientific missions were that prepared paper samples with bio-based polymers will have a sufficient impact and will be appropriate at certain packaging industry. Till now, the results have shown improved properties which are going in the right direction for packaging material, and more analysis on these samples will be carried out. Future works are therefore analysis on the FTIR, DMA. We would like to determine water absorptiveness, tensile properties, grease, moisture, and microbial barrier properties, which are of course very important for the materials used in the packaging field. The final results will also help to produce new materials and to develop at this visit and to research further within Actinpak Action. We will also in the future collaborate with the host faculty in Sofia. I would like to thank Cost Action, Actinpak, for all support and for giving me the opportunity for this mission. Thank you.